So here's the rover, here's his rummy. So it's probably best if I just take you through the components that we've got on board and just give you a rough overview of what's going on here. So we'll start at the back and we'll work towards the front. So we've got wheelchair motors, really standard. You can buy these off any kind of online electronic motor supplier. You can buy them in Europe, you can buy them in China, you can buy them in America, you can buy them anywhere. These have a standard kind of mounting as well. So our frame has just 3 bolts to mount the wheelchair motor on. The only difference we've made to this is we've put some encoders on the inside here so that we can tell when the wheel does a full rotation. We can calculate that as well, but having encoders on just makes the whole lot easier. This is the only drive that we have on the Rover. It's only 2-wheel drive. There's no need for 4-wheel drive on this, though we do have steering on the front. So moving back towards the centre of the Rover, this is the bit that does the guts. This is an X-Carve CNC, so this is a real maker-friendly CNC. We've replaced the firmware so that the CNC is actually a lot smoother and a lot faster than the stock firmware that comes with it. Again, this will all be open source, so you'll be able to download the modified firmware to have a nice smooth action on the weeding tool. At the top here, we've got a Raspberry Pi Zero with a Raspberry Pi camera inside. And this kind of drives the whole of the weeding process. So what happens if you imagine you're on a standard 25-40 metre bed is that the rover will move itself autonomously into place. We take a photo here. From the photo we create a black and white image mask, and then we run a little bit of artificial intelligence, a bit of machine learning over it to distinguish between the weeds and the crops. Once we've done that, we then plot a route between all the crops, and this arm moves between all the salads, just taking out any weeds and leaving the dead weeds in the soil to be reabsorbed. We find that passing over once a week actually is enough to keep the weeding down. It stops them coming through. So the aim really of this is weed prevention rather than actually, removing weeds and taking them out. There's a lot of different systems out there. We just take them out the soil, leave them in place to rot back into the ground. What do we got here? Okay, so power wise, I can open this up later. We've just got a very simple 76 amp hour truck battery. This gives us more than enough power for 8 hours to work a full working day. Really simple standard charger, recharges overnight. Nothing complicated there at all. Nothing else really to say about it. It's a truck battery. Now this is a new addition to the Rover. We had freewheeling wheels on the front. And what we found, that introduced a lot of noise into the system. So if the wheels are just left to run freely, if you're going forward, the wheels are kind of doing this. And the Rover then has to compensate a little bit more. So as a relatively new addition, we put stepper motors onto the top here. So we can now control the direction of the Rover from the top, and it's a lot more solid. This was a really, really good idea of Peter's to put these in at the last minute, because it just keeps the Rover really, really on track. It also aids a lot in a big leap forward that we made this year. Actually, we were originally running on rails, and one of the things that we've put in this year that we're really, really excited about is that the Rover is now autonomous. So what we have is a modified line following algorithm where we actually use the top camera, we take a photo of the crop and we plot a route following the crop. So we've gone from a system now where the Rover, the farmer had to intervene continuously by changing sort of speed, or stopping the Rover if he's doing it sort of manually with the control, or just setting the Rover to go forward manually in steps, having to continuously sort of control the Rover. Now it's autonomous. We can set it at the front of a bed. We can say follow the crop and just leave it for an hour, 2 hours to go off and weed the whole bed. So that's a real leap forward this year. Internally here, it's going to be a little bit difficult to have a look inside, but this is the brains really. We've got a Raspberry Pi 4. We've got some Arduino. We've got an Arduino here which controls the CNC. Inside a little box hidden here, we've got more Arduinos with controllers to control the power. And as I said, everything runs off a Raspberry Pi 4. Another important feature that you'll see on a lot of agricultural equipment: emergency stop. It does exactly what it says on the tin. It stops the rover. We're not just stuck in a lab designing something that we think is great. We're out here and we're working with farmers. We're using the rover to help cultivate, and we're getting valuable data. But not only that, as valuable as the data is, we're getting valuable input from the farmers that we work with. Because it's no good doing this in a lab, then coming out and saying, oh, it works like this, and the farmer's saying, well, we don't work like that. So if you work with the farmers as you're developing a piece of agricultural equipment, you're going to get something which is inherently useful to them. So it's a very, very good marriage of development, really.